Problem 11.2. So suppose x1, x2 are the values of the random sample of size 2 from a population having a uniform density with alpha equals to 0 and beta equals to theta. And theta is some parameter we want to estimate. Now find the value k such that this interval from 0 to k times x1 plus x2 is a 1 minus alpha confidence interval for the theta, where the alpha, so we need to consider in two different scenarios, the one alpha is less than equal to 1 half and alpha is greater than 1 half. Apparently this is more interesting. This is just for the B part B is just for practice purpose, because the alpha is supposed to be, we need to be a little bit small, right, for this confidence interval to be large. Okay, but anyway, let's think about the part A first. So the key here is that we first observe that the joint distribution of this x1, x2, because we have only two of them, and they're independent, and they're both following the uniform distribution with 0 and beta as the parameters. So we know that the joint distribution of them will be just the product of their marginal distribution, which are both 1 over theta over the interval 0 to theta. Okay, so that's why their joint distribution should be 1 over theta times 1 over theta, and then that's 1 over theta squared. So that is the joint distribution. So our purpose is to find this value k such that the probability of committing, so the confidence level of this interval should be 1 minus alpha, meaning that the probability that the theta falls into this interval should be equal to 1 minus alpha. Okay, so remember that x1 and x2 are following this distribution, or following this PDF here. Okay, so we can make a rearrangement of this. Apparently theta will be greater than 0, so we don't need to really worry about that. Looking at this part, so if theta is less than this, means that the probability that theta is greater than, or x1 plus x2 is less than theta over k will be equal to 1 minus this probability, which will be alpha. Okay, so these two are actually equivalent. Now let's look at this. So this says that the probability that this happens is equal to alpha. Okay, so the x1 plus x2 is less than equal to theta over k. Then look at the picture on the right. So this part is the domain, right? Is the domain here. Okay, now we know that the PDF is a constant over this region. So if I want to make sure that so now this x1 plus x2 less than equal to theta over k is this area, is this line, right? Equals to theta over k is this line. So less than equal to theta over k will be everything below it, below this line. But it has to be inside this square as well. So that's why this part is where the x1 and x2 can live on. Okay, so the region here, so we're supposed to take the integral of the PDF over the region, this triangle region. So that is, I denote this region as A. So you need to take the integral of this PDF over the region A. But remember that this PDF is a constant here. So the integral of this PDF over A is just this constant times the area of this A. So the area of this A, because we see that this line takes the intersection theta over k at this point and also at this point. So the size of the triangle is, the area of this triangle is just half times the square of theta over k. Okay? And also we know that the value of this guy is just the 1 over theta. So we just have this. And multiplying all of them together, we get the alpha. So this is this value here, and that should be equal to alpha. So by this we can solve for the k, and turns out that the k equals to 1 over square root of 2 alpha. Okay, so that is how we get the value k when the alpha is less than 1 half. So what the key is why it is less than 1 half makes a difference here is that we know that over this region it is constant. Okay, so that means if you have a line here, then the line has to be below this line here, because you have a line here, the intersection of that will be just the square here, that will be just a half of the probability, or just probably 1 half. So if your alpha is less than 1 half, you have to make sure that there's the line something like this, not going there. Okay, so for alpha greater than 1 half, then that will be the case where the line will be somewhere there, and that's the case here. So if for alpha greater than 1/2, we still need to find this k such that this is equal to alpha. This is probably equal to alpha. Now the line is here, and we need the probability equal to alpha. Again, we need to take the integral of the PDF, which is a constant, remember that, over this area B. So over this region B. So it's essentially the integral equals the area of the B times the constant here, which is 1 over theta squared. So now the key is to find out the area of this B, and this is the B area. And apparently there are many ways to find it. I took an easy way that just take the area of this square and subtract this triangle here. So to figure out the size of the triangle, we just need to notice that this line here is equal to this line. Okay, and the difference between sorry, it should be, let's see, it should be this. So theta over k should be bigger, so that would be, so this length here. This length here should be equal to theta over k minus theta. Okay, so that means this line here should be 2 theta minus that, because it should be theta minus theta over k minus theta. So my apologies here. This should be that. Okay, so the size of the triangle should be 1/2 times 2 theta minus theta over k squared. Now that is just the area of the triangle, and the total area of the square is theta square. So it's a theta square, subtract that, times the area, times the 1 over theta square, and that will be equal to alpha. So by this, we need to solve for the alpha. So let's see, I think by solving this, we erase this. It's not correct. So now we can see that they all have this sigma square. So here, trying to solve that. So this is equal to 1 minus 1/2, 2 minus 1 over k square equals to alpha. So by moving this alpha to the left and multiply by 2, so we have a 2 times 1 minus alpha equals to 2 minus 1 over k squared. Okay, so this is equivalent to taking the square root. 2 1 minus alpha equals to 2 minus 1 over k. And this is equivalent to saying that the k is equal to 1 over 2 minus square root of 2 1 minus alpha. Okay, so that is the solution. Hope I didn't make a mistake. That will be the solution. Okay.